As, um, the strange signifies the relationship correlation between two variables. It means how one variable will change due to the change in the other. So values that are close to +1 or -1 indicate a strong relationship. These values are attended if the data points fall on or very close to the line. So the further the data points move away, the weaker the strength of the linear relationship. Where there is no practical way to draw a straight line because the data points are scattered, the strength of the linear relationship is the weakest. Why I have to read a whole paragraph here because I like you to give some sense of the what is the strength and what is the relationship correlation between two variables. So let's imagine first, and when you see the graph and you come back to see the definition of the strength here, okay, you will understand um, the strength of the uh, two variables, okay, and we should say the strength between two variables here very clearly, and also the direction. Okay, the direction of the line. Okay, you're gonna plot the data into the two-dimensional space, and you are going to identify the line, the linear line that indicate the slope. The slope of the line indicate indicate uh, the direction. Okay, a positive linear or negative linear relationships between variables. If the line has an upward slope going up, the variables have a positive relationships. This means an increase in the values of one variable, x increases, will lead to an increase in the values of other variable y also increases. A negative correlation depicts a downward slope going down, the line graph going down. This means an increase in the amount of one variable leads to a decrease in the values of another variables. So let's have a look here. Uh, this graph, it shows the straight line that fit with the plots, or with the scatter plot. So it depicts a correlation of almost +1. Why? Because the scatter plots are nearly plotted on the straight line. It is not difficult um, to identify the line graph that represents the scatter plots, right? And the slope is positive. It means that if one variable increase, for example, x, if x increase, y also increase. Here, if x increase, y also increases. So it shows a positive linear line. What about median positive correlation? What about it? Okay. And this figure also show positive correlation, but not 1.0. It may be 0.7, 0.8, 0.9, but still positive. Okay. It shows a pretty strong linear uphill pattern. But compared with the first one, large positive correlation, you can see, okay, there is a distance between the plot, between each dot. Okay, if you project the dot to the line, so you will see that there is a lot of distance, okay, from the dot to the line. How about this figure? small negative correlation. It's opposite, right? It's going downward. Okay. You can see the scatter plots are not as close to the straight line compared the early examples. So it shows negative linear correlation of approximately maybe minus 0.4, 0.5. Okay, the change in one variable is inversely, it means opposite direction, proportional to the change of the other variables as the slope is negative. You see, x increase, but y decrease, all right, with the negative correlation. Okay, x increase, but y the opposite, decreases. What about this graph? Okay, this is weak. It represents weak or no correlation. What happened? Here you can see that the scatter plots, the plots are far away from the line here. You can see the distance, okay, bigger and bigger, okay, far away from the line. It is tough to practically draw a line. Sometimes it's very difficult to identify the straight line, the straight line that represent the scatter plots. So the correlation is approximately, let's say, plus 0.15. And it cannot be judged that the change in one variable is directly proportional or inversely proportional to the other variable, because you have weak relationships between the two variables, or no correlation, okay, is identified. So this is very popular. So let me make a conclusion. We still have 2 minutes left. Okay, let me make a conclusion this way. So Pearson correlation coefficient is very popular. Okay, R, okay, can represent the measurement of the strength, or the strength of the relationships between two variables, and also the direction or association with each other. So very easy for computing a Pearson correlation coefficient. You should establish the coefficient table, R table, and then you compute it. Okay, you can enter this value into Excel, and you can put a very simple formula. It can give you the total, okay, very easily, and then you can interpret the Pearson correlation coefficient, okay, by using this table to represent strength of association and also the direction. Okay, it depends on large positive correlation, medium positive correlation, small or weak no correlation, and that's it. I hope you understand, and this is not difficult. It is quite popular, and it is very useful when you set up research questions, okay, and you want to compare two independent variables, okay, you can think about correlation coefficient and also the correlation test. Thank you for paying attention. I think that is all for the most important things in part 1. Okay, and let's see other videos, okay, in the part 2. Bye bye.